Hello friends, welcome to my YouTube channel Spider Learning. So today we are going to discuss the chapter Electric Charge and Field from Electrostatics, and the topic that we are going to discuss is first one, properties of charges, then Coulomb force. So first start with the properties of charges. Okay. So properties of charges. First property, charges. First property, charges. Charges are additive in nature. So what does it mean? The charges are additive in nature. What does it mean? Basically, the charges are scalar quantities. Okay. So when we consider the system, a system of charge, charge system, then we can simply get the total charge by adding algebraic addition of all the individual charges. So let's do it. Suppose we are considering a system, and in the system there are Q1, Q2, Q3 Qn number of charges. So what is the total charge? So total charge of the system is Q total equal to Q1 plus Q2 plus Q3 plus plus Qn. Here we should keep in mind that the addition will be done according to their sign. That is, the sign should be positive or negative. Okay. And another thing, charges are scalar quantities. Scalar quantities. So we are able to do it in this manner. Okay. The second property is the charges are conserved. Conserved in nature. Okay. So charges are conserved in nature. What does it mean? It means that in a system we can never create any charge or never destroy any charge. That is we can transfer charge from one body to another body. Let us consider an example. We have two systems. One is glass, another is silk. So here in this situation the total charge is 0. Total charge equal to 0 plus 0, that is 0. Now if we rub these two, glass and silk, then suppose glass acquire positive charges plus Q and silk acquire negative charges minus Q. So total charge equal to plus Q then minus q equal to 0. So it's obey the law of conservation. Okay. Now the third property is the property of quantization. Okay. The third property is charges obey law of quantization. Law of quantization. So what does it mean? It means that the total charge, if Q be the total charge of a system, then it is nothing but the integral multiple of electron. So where n equal to, it may be 1, may be 0, 2, 3, up to infinity. And E is the charge of an electron, and we know that the charge of an electron is 1.6 into 10 to the power minus 19 Coulomb. Okay. Now the fourth one tells like charge repel each other and unlike charge attract each other. The fourth one, like charges attract each other and unlike charges repel each other. Okay. Suppose we are considering one positive charge plus Q and another positive charge plus Q, a negative charge minus Q and another negative charge minus Q. These are the example of like charges. So here they will repel and they will attract. Sorry, they will also repel because they are like charges. Now if we consider one positive charge and another negative charge, then they will attract. Okay. So these are the four properties of electric charge. Now we are going to explain the third number property with an example of a numerical. Okay. So now we are considering 1 Coulomb charge and we are going to calculate the number of electron in 1 Coulomb charge. Let's do it using this quantization property. Okay. So our task is to calculate number of electrons in 1 Coulomb charge. This is our task. Okay. For solving this problem, we are using quantization property of charge, which is Q equal to plus minus Na. So here Q equal to plus minus Na, but we are writing only any. We are interested only to find out the value of n, and it's a number, so sign is not necessary here. So n equal to q by E, and we know that according to question q is equal to 1 coulomb and charge of an electron is 1.6 into 10 to the power minus 19 coulomb. Put the values. This is 1, this is 1.6 into 10 to the power minus 19. So if we put it here, then it becomes 10 to the power plus 19 divided by 1.6. So after simplification, we can write 10 to the power 19, it's okay. Then it's 16 by 10. Then it becomes 10 into 10 to the power 19. Here 16. Now we can solve it like this. So we are simply putting 1 0 with 10. So it's become 100. So it's 16. Now if we divide here 16, so 96, then it become 4. We put a point here, that is 0. Then 16 to the 32, then it's 8, then 80. 16 5 is 80. So the value is like this. Here we should put 18. So it becomes 6.25 into 10 to the power 18, or we can write 625 into 10 to the power 16 number of electrons are there in 1 coulomb charge. So the relation q is equal to plus minus Ne. Here we are simply writing Ne because we are interested to find out a number. So plus minus sign is not necessary to put here. Okay. So the value is 625 into 10 to the power 16. That's all. Now we are approaching towards Coulomb law, Coulombian force or Coulomb's law. So Coulomb's law is very important for electrostatics, for the study of electrostatics, all the phenomena of electrostatics. Okay. Okay. Coulomb's law. So Coulomb's law, First of all, we should study the statement and then its mathematical form, and then we are going to explain the concept of constant here, which is very important. So what is the statement? The electrostatic force of attraction or repulsion, electrostatic force of attraction or repulsion is directly proportional to the product product of the magnitude of charges. The electrostatic force of attraction or repulsion. Here we should introduce in another word, which is uh, the electrostatic force of attraction or repulsion between 2-point charges, which is quite important here introduced. So there little modification is necessary. The electrostatic force of attraction or repulsion between 2-point charges. Point charges is directly proportional to the product of the magnitude of charges and inversely proportional to the square of the distance between the charges. Okay. Since force is a vector quantity, so in the statement we should indicate the direction of the force. So the last line is like this: the direction of the force, it may be attractive or repulsive. Okay, the direction of the force is along the line joining the 2-point charges. Okay, so here the word point charges, when we are considering two charges which are very small, and the small in the manner it is small, the distance between them in comparison with their distance it is very small. The distance between the charge is very big and the magnitude of the charge is very small. So we are considering the charges are point charges. So the force may be attractive or repulsive. When it will be attractive? When the charges are unlike, then it is attractive in nature. When it is repulsive? When the charges are like charges, according to property of the charges, the force is repulsive. And how can we measure the forces? The force is proportional to the product of the magnitude of the charges. Magnitude of the charges means we are not considering the positive or negative sign of the charges. We are just multiplying the values of the charges, and is inversely proportional to the square of the distance between the charges. Okay, and the direction of the force is along the line joining the two charges. So this is the statement. Now we are going to derive the mathematical expression of the Coulomb's law. Okay, so for this we have to draw a diagram. Let's do it. So during drawing the diagram, it is very important to draw it for both category of charges. Okay, for like charges and as well as for unlike charges. Okay, so Here we are considering a charge Q1 which is positive and another charge Q2, both are point charges at a distance r. It is also positive. So the direction of the force is this way and the direction of the force is this way. But when one charge is positive and another charge is negative, the direction of the force is this way. That's why both the diagram is necessary to indicate the direction of the force. Okay. So suppose the two charges are Q1 and Q2 separated by a distance r in vacuum or free space or air medium. Okay. So here medium plays an important role. So it is mandatory to write here the concept of medium or free space or air medium or vacuum. Okay. So now according to the statement of Coulomb's law, we have F proportional to Q1, Q2, that is the product of the charges, and F is also inversely proportional to the square of the distance. Here we can write when R is constant, and here we can write when Q1, product of Q1 and Q2 is constant. Okay. Now combining these two relation, that is force is proportional to the product of the charges and force is also proportional to the square of the distance, we get a conclusion like this. Therefore F proportional to Q1 Q2 by R square. So this is a proportional relation, so we need a constant of proportionality. So we are writing it like this: F equal to K Q1 Q2 by R square. So this is basically the mathematical expression of Coulomb's law. F equal to K Q1 Q2 by R square, where K equal to electrostatic constant. Okay. So there is a value of K in SI system. In CGS system its value is 1. In SI system we are actually interested in SI system, not in CGS system, according to NCERT syllabus. Okay. So in SI K equal to 1 by 4 pi epsilon naught and its value is 9 into 10 to the power 9. So now there is a question, what will be the unit of K constant? So if we consider K, then if we multiply the F by R and then divide it by Q1 Q2, we will get K. So the K equal to, we can simply write F R square divided by Q1 Q2. The SI unit of force is Newton and the SI unit of distance is meter square, and the SI unit of charge, there are two charges, so it's Coulomb square. So you can write it Newton meter square per Coulomb square, or simply Newton meter square C to the power minus 2. Both are correct. Okay. So the unit is Newton meter square Coulomb to the power minus 2. So this is the value of constant K. Okay. So now there is another question, what is epsilon naught? Epsilon naught is the permittivity of free space or vacuum, where we are considering the two charges are kept in air or vacuum. Basically in air and vacuum, the value of epsilon naught is almost equal to, not equal, almost equal to. So epsilon naught is 8.854 into 10 to the power minus 12. Now another question, what should be the unit of epsilon naught? So for finding out the unit of epsilon naught, we are doing a simple calculation here. Okay. F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. We are interested to find out the value of unit of epsilon naught. So epsilon naught equal to 1 by 4 pi. Basically it is a constant. Then Q1 Q2 by F R square. So since it is a constant, so it has no unit. So we can write Q1 Q2 by force into distance square. So Q1 is Coulomb, Q2 is also Coulomb, that is Coulomb square. Force, the SI unit of force is Newton and the distance is meter square. So it becomes Coulomb square Newton to the power minus 1 m to the power minus 2. So the unit is Coulomb square n to the power minus 1 m to the power minus 2. So this is the unit of permittivity of free space. So it is what? It is the permittivity of free space. Permittivity of free space or vacuum. Okay, epsilon naught is the permittivity of free space or vacuum. Okay, so that's all for today. Thank you for watching the video. We'll meet again with another video. Thank you.